This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett, and on today's show, we've got a bunch of great topics. Number one, GE choosing Veolia to recycle turbine blades. It's actually a really interesting story about the way they intend to use that in cement mix. An interesting article by the consulting firm Wood Mackenzie predicting Siemens Gamesa Renewable Energy, Vestas, and GE, and how they'll increase their market share over the next decade. Interesting article about Amazon committing to buy 250 megawatts of power from Ørsted in Europe. And then in our tech segment, we'll talk a little bit about Timken and their commitment to invest $75 million to increase their capacity in wind energy. And lastly, we'll talk a little bit about green ammonia and Vestas backing a wind plant to do that. So, Alan, let's start with GE and Veolia. So obviously we've talked before about wind turbine blade recycling being a big problem because these things are enormous and there's no good way to put good place to put them. Right. And they don't really just like mold well into the environment. I mean, we're just burying them at the moment and trying to find places to put them. Right. So tell us about this article about Veolia and their agreement of how to process these.
So GE has been working for the last couple of years on how to recycle the blades because some of those blades are starting to come out of service, and they've been looking at recycling for a while. But obviously, it's where do you recycle it? Where is it going to go? Where are you going to put it back into the ecosystem? And it looks like they found a home in the cement industry. And the article is interesting because it was addressing sort of two different pieces to the cement. When you manufacture cement, it kind of goes through a kiln process. So they're using but first of all, they grind up the blades, which is a massive problem because when anything that's made out of epoxy and fiberglass is inherently tough, and to grind that into usable chunks or pieces is not easy. So it's like putting it through a gigantic paper shredder, but on the world's most largest paper shredder, industrial scale paper shredder. It's got to sit there and just kind of chew at it. If you ever try to cut, fiberglass with like a grinder or something, it gets hot and it melts and it gets gooey. So you can't. There's only certain ways to attack that problem. So grinding it up first, the big problem. But once you get it ground up, now you have all this fiberglass, which is a great additive to any sort of cement mix because it actually prevents the cement from cracking and coming apart because you got these fiber binders that hold it together. So you have this engineered cement system, which is really useful. But the second part was they must be burning off the epoxy, and epoxy does burn. So in that kiln process, it sounds like they're reducing the amount of coal used to heat these kilns up by burning the epoxy off is what it sounds like. So I kind of went about that part of it a little bit. Obviously GE is full of really bright engineers. They've been that way for 100 years. So I'm sure they looked at what the emissions out of that are and what the trade-off is, maybe just going through some scrubbers. But that is fascinating because it wasn't a few episodes ago, maybe 20 episodes ago, we were talking about how they're burying blades in Iowa, basically just digging a hole and dropping them in and putting dirt over them. And now a couple months later, we're recycling them. So maybe the PR from that burial had something to do with, really kicking this into high drive. Don't you think that had something to do with it, the PR part of this recycling bit?
Yeah, maybe. And of course, well, you've probably seen these shredding videos on YouTube too. There's, whole channels, I think, where people are just tossing different items into these industrial shredders. They have these shredders to shred whole cars, right? They shred engine blocks. So it seems like those are definitely up to the task. But like you said, this is a really long. I mean, you're feeding potentially 100 meters into one of these,
right?
Almost like wood chipper devices, and they can definitely handle it. But like you said, it's a slow process. It's got to be, I'm sure, like the right kind of teeth as they grind it up.
Oh, yeah.
I mean, that seems like it makes sense, but like you said, there's probably a lot of, and that's really interesting. It says up to 28% of the blade weight would actually provide energy for the chemical reaction that would happen in the kiln. So it does sound like a pretty good fit, which, yeah, that seems like probably one of the best solutions that we've heard of thus far.
Right, and we haven't really heard much in Europe on blade recycling. It seems like what we have heard has been in the United States. Mostly probably because there's a lot of wind turbines in the United States and they're coming of age, so they need to do something with them. But I haven't heard so much in Europe, and definitely haven't heard anything in China about it. So it is good, right? If you can recycle it and use it for another highly complex, energy-intensive process, fantastic. So sort of hats off to GE here.
So moving on, Wood Mackenzie, the consulting firm, I know they own greentechmedia.com. They put out an article that says the top 3 turbine OEMs are poised to, really boost their market share between now and 2029. Yeah. So potentially going from 43% in 2019 to 60% a decade later in 2029. And that includes Vestas, Siemens Gamesa Renewable Energy, and GE. So how do you feel about this? I mean, that's a lot of conjecture. Yeah. Obviously, they have some of the world's brightest consultants, but that's a long period of time to really speculate on, market share and growth and all that for businesses.
I think so too, especially if you're going to invest. And Dan, you do investing, so you have a sense of it. Would you invest in something like that had a predictive return 10 years out? I don't think that I would. It's just too much risk.
I mean, I just don't know that we know what the world looks like in 2020 and 2025 even. Right. I mean, the world's very different today than it was in 2015, right? So
yeah.
I mean, it seems like obviously these projects have a longer trend, right? Like we talk about some of these new wind projects being built, and they're not even going to be in, complete for 3, 4, 5, 6, 7 years in some cases. Yeah. So I guess you can predict out pretty far as like, contracts and what they're proposing to do, but just 10 years from now, I wouldn't personally take any stock in what's going to happen 10 years from now.
I wouldn't either. Honestly, it wouldn't make any sense, just because if you think about the leadership of any corporation, and all it takes is one significant event, earthquake, fire, in one of those, and all that goes to zero. All the predictions go to zero.
Well, and also just like Paul Geip was talking about, like there's a lot of technologies that are going to get a lot cheaper in the next 5 years. I mean, he talks about it's a lot easier to put solar. If you're a homeowner, rather than put a small wind turbine out, it's way easier and way cheaper to put out solar panels. So it's hard to really say even in 5 years, not even 10 years from now, where battery technology leads us, where, all these different things. I mean, Tesla's done so much for pushing technology, as far as electric storage and all that. It's just hard to know where we're going to be.
Think about it this way. What if we were able to develop fusion power in 2025? Do we have wind? Not at the scale we do now. We won't. That's a huge game changer, but in all of the 20th century, think about all the game-changing things that happened, from flying to having running water in homes and sanitation and automobiles and television and radio and all those different things that no one would have predicted. Why would that be any different in this century? Right? I don't think that it will be. So it's so hard to predict. And when I always hear a 10-year plan, I always think back to the Soviets' 5-year plans, which never were predictive of anything. And then I think, well, if the Soviets couldn't do 5, so we ought to stick to maybe 2 or 3. Maybe 2 or 3 years out, we could quasi-predict. And that's about the limit of prediction, I think.
Yeah, and I would tend to agree. And we've talked a bunch of about just different books we've read. And like I said, for me, reading a bunch of Nassim Nicholas Taleb's work, and he's constantly talking about predictions and randomness and
Right.
the stock market, and how people just need to be aware that much more of it is random than they think. Even when they're making seemingly good decisions, like, hey, we thought this was going to happen and it did. He's like, that was a lot more random than you thought it was. And that humans are just really not good at predicting. They're just really not.
Exactly. So what value do these predictive articles have? Don't you ever wonder that? Like you see, we're in 2050, we're going to be flying in spaceships. And you're like, whatever. Okay. So you just kind of just out of hand discount it. But 2029 is like, okay, it's close enough that I could see it. But who's acting on that? Right? Because investors like you at sort of the individual level are not reacting to it. Is it just a PR play, or is it trying to push marketplaces in different, which Wall Street does all the time?
Yeah.
Well, what's the point? What's the point of having an article like that? It's like saying you're going to know what Apple's producing 3 years from now. You have no idea. I don't have any idea. I'm probably closer to it than some people, and I have no idea. So what's the point of the article?
Yeah, it's a good question, and I'm certainly not deep into the consulting world, and I think analysts are just paid to analyze. It seems like and just try to make the most. I don't know, just try to speculate on what the world's going to look like. But I think that really is more of what it is. It's speculation rather than.
Yeah, right. I think it's speculation. And from the engineer standpoint, having watched the analysts come into a couple of different companies that I've worked for or participated in, their ability to predict the future has not been very good. And when the companies have taken the direction of the analysts, it's never really worked out. Now, not say that it doesn't in general work out, but it hasn't worked out in the technology companies I've been involved with. And I always think, who knows more about the characteristics of the companies and the company themselves? If you want to know what's going to happen inside of, pick it, Siemens Gamesa 2 years from now, it's not very hard to find out. I mean, knock on the couple of the engineers' doors over there and know that they have a pretty good idea where the company is going in 2 years, for sure, way more than an analyst may, right?
Yeah. Well, and Apple recently, I mean, we've talked about, their new computer tech. Apple just released their new MacBooks with the M1 chip. Well, they've been developing that. That didn't happen in the last 9 months. They've been developing that chip in secret for what? 5 years, probably.
Longer.
Slowly
15.
Putting all the processes together. Yeah. But it's just now to most of the public, hey, they've got new chips. Like, hey, I think the story broke that they were developing it, that this was coming maybe 9 months ago, a year ago. So, and of course, if that's when the public learns, there's a lot of people who are a lot deeper than that, who are aware that was coming, but then there's still,
but no one,
that's been going on for a long time, and people just didn't know.
Isn't that interesting though, Dan? Because I do think you bring up the right point, which is that obviously all the engineers working at Apple and the products they were developing had that technology in it for quite a while, right? But I didn't read any articles talking about the future computational ability of basically simplified processors in any article, in anything in the last 5 years. But in the last month, there's been a whole plethora of them. Where were you a year ago, right? Mm-hmm. So if you're analyzing the industry, how do you miss that one? And how does it not get into the general public's knowledge? Like, hey, Apple is going to kill it in a year. Buy Apple. You didn't hear that. Maybe I missed it. I don't think so. I'm pretty tied into Apple.
I didn't hear it either.
Right? So,
yeah. And now, this is kind of the same thing where Intel has been a massive player in chip production,
yes,
right, for the longest time. Right. And now, so if you're to forecast 5 years ago that Intel, who's already dominant, is going to continue just to increase their market share, which maybe you'd say that, maybe you wouldn't, but just as a hypothetical, would you have foreseen that Apple was going to come and basically hurt them big time?
No.
It's a huge, Intel's going to be really hurt by this.
Oh, massively. So, yeah, it's like predicting that someday you would not have an IBM computer on your desktop, because there was a while there you thought this is going to happen forever, or always thinking that Microsoft is going to be the greatest company in the world, and it just isn't. Things come and go, and it's so hard. It's such to predict that, I think, is like going to Vegas. You might as well go to Vegas, because at least the odds are somewhat controlled there, right? You kind of know what you're walking into. You don't know what you're walking into to any business, because it's and the way to think about a business from the engineering standpoint is it's a living, breathing organism, because that's essentially what it is. And there's a lot of ways for those organisms to go wrong. And history has shown us that once big companies get going in a certain direction, it is really, really hard for them to make any sort of adjustments going forward. So if there is new technology or a smaller company that's more adaptive, the big companies are in trouble. Go to Kmart, go to Sears, go to JCPenney, right? When I was a kid, they were the places where you would shop, and they just controlled the whole marketplace. They're not around anymore.
Mm-hmm.
And that's 20 years ago, right? So it doesn't take long for the world to change substantially. And that's why I think all these articles you got to take with a grain of salt.
Well, and one more thing about, this isn't forecasting, this is a real thing, but Amazon has signed a deal with Ørsted to buy 250 megawatts from their 900 megawatt Borkum Riffgrund 3 wind farm. And that's going to help Amazon get to its target of being 100% renewable by 2030 and net zero by 2040. So obviously wind power is here to stay, right? No one's debating that. It's going to be a percentage, even if we got fusion power, right? Wind power is still going to be a large chunk. Like there's a lot of, what's the word here? Diversity in just where all of our power comes
Always
from.
Has been.
So Amazon's committed to buying a large chunk of it in the future with a PPA with them. Do you feel like this is going to get other companies to follow suit? I mean, Amazon's the big bad wolf in some regards here in the US, and of course it's beloved by a lot of consumers as well. But I mean, is Apple or these other big companies going to be doing the same thing, following suit?
I think they're going to try. Anytime you can lock in one of your key constraints to growth, which is power consumption, if you can lock in long-term agreements on how much the cost of power is, you really want to do that. You see the same thing in the airline industry when they can buy long-term contracts on fuel pricing where they know what that is, even if it's slightly higher than what they really are willing to pay. At least they know what it is. So from an Amazon standpoint, this is a two-part play. One, it's a PR relations thing where they're trying to show themselves to be very green and eco-friendly and all that. But you got to think about how they operate their business, right? Their business is trucks and airplanes and delivery vehicles, and it's going to be drones pretty soon, right? So they have a lot of vehicles on the road, and now they own or operate a lot of aircraft. They're starting their own airline fleet. That's essentially what they're doing because they had that break with FedEx. So there's just a lot of gyrations. So part of it is somewhat diversionary, like, hey, we want to be green, but at the same time, we're delivering things like UPS every day. But I think the bigger picture is consistency, knowing what your costs are going into a particular year or a month, and energy is one of those big costs for them. It doesn't really seem like it would be. Ever been to an Amazon warehouse? Those places are huge. They take a lot of electricity to run and to heat and operate. So controlling that energy price is really important for them going forward. So it's not all benevolent. It's a lot about controlling costs.
All right, so moving into our engineering segment here today. First up, we're going to talk about Timken. So obviously Timken is well known for producing bearings in all sorts of markets, industrial equipment, food and beverage, all these assembly lines. You see, fruit rolling down assembly line. It's probably filled with Timken bearings. Automotive, rail, agriculture. I mean, everywhere, like bearings are everywhere. So, but they've recently committed $75 million to improving one of their LEED certified factories in China. They're going to scale up production capacity at their sites in China and Romania and other places, and also consolidate some sites into a bigger campus. So this obviously, it seems to certainly make sense to me, right? I mean, wind energy is getting bigger. It's very well accepted. They're why wouldn't companies want Timken bearings in their in their nacelles? So how do you feel about this move for Timken?
You definitely want to have reliable bearings, which is when you go to, that's why you're at Timken, right? And when we had Jordan Hedges on, one of the discussions that he brought up was, hey, bearings in direct drive wind turbines were a problem early on. And so getting reliability, because that's always rotating, or should be. I mean, hopefully those bearings are always rotating on some level. That you think about how long those bearings have to last and how reliable they need to be, then you get narrowed down to the number of suppliers that actually create those things. And knowing that a significant portion of the wind turbine marketplace is in China, and there has been some reductions in tariffs that have happened, and which I always think is a very odd thing for China at times. It seems to the way those tariffs work in China are very selective. And not to say they're not selective in the U.S., they totally are. But what they're selective about is odd. And especially when we were talking about Siemens and GE and having more market share, part of that is driven by the opening of China to some level, right? So it seems like there's a big emphasis of drawing some of these wind turbine companies that have massive scale into China, because up to now it's been pretty much a closed marketplace. They've been building their own products in country sort of by themselves, and now they're trying to bring in some foreign entities to build larger turbines. Clearly, when you get to a certain point, you really need a lot of help. Because as like with the GE Haliades and all those wind turbines, as they get larger, all of a sudden those components that were critical now are super critical. So your technology, it doesn't seem like there's a lot of technology in bearings. There's a lot of technology in bearings. There just is. Yeah. Right? So the metals and the alloys and how they're made and the heat treatment and on the machining that has to go on has to be just right.
Oh, for sure.
Right?
Yeah, absolutely.
Right. So I think that's part of it. And we got to wonder, too, if Timken is also thinking sort of a longer term, broader market into more of a heavy industrial base. Because there's not a huge industrial base in bearings, right? Especially of that size. So there's not a lot of competition out there right now. There isn't. So you just kind of wonder how they're setting themselves up for the future again. They're looking 2-3 years ahead and saying, "Hey, this is where we want to go. This is where we want to roll the dice in, and we see a marketplace there, so we're going to dive into it." And that all makes sense. If you see an opening that's probably that massive, you really can't not go through it. And so it's one of those interesting little technology pieces to watch.
Yeah, absolutely. So last item on the docket today, Vestas is backing a commercial green ammonia plant, and of course this is overseas in Denmark. And the goal is that they're going to have both wind power and solar power powering an electrolyzer that's going to produce hydrogen, which will be processed into ammonia. And this is obviously for fertilizers and other uses. We mentioned this project, which is the Power to X.
Yes.
Briefly in a different podcast episode. Yeah. So why do we need ammonia? Obviously, agriculture, we need it, but are there other uses for it commercially?
Fuels, right? It's part of fuels. Fertilizer is a huge industry, by the way. You think of all the way
we do need food. We do need food.
And the way we concentrate our landscape now, where we focus on certain parts of the country, at least in the United States, where you're reusing that same soil all the time, it is important to put nutrients back in it. Otherwise, it's impossible to grow crops. So you have to fertilize to get the yield that you're looking for. And because the density of crops has gone up so high, if you look at 100 years ago to now, the density is way up.
Monocultures are terrible for the environment. They're just terrible for the quality of the soil.
Right. So one of the, having grown up in Nebraska, the university there and a lot of the universities in the United States and the Midwest have agricultural studies, right? And that's part of it, is knowing how to treat and maintain the soil. And you'd be surprised how much the state actually monitors how well the soil is doing there. So fertilizers all around the world are important to sustaining life. And so usually the way they make fertilizer is just part of a combustion process of burning natural gas or something. And you take those byproducts off and make them into fertilizer. So they're trying to come up with a more quote unquote carbon dioxide neutral system where if you can create hydrogen from electricity, then you can combine it with other molecules and make these chains. Because it wasn't just on the ammonia side where the power to X was discussing, because Airbus was also talking about using the same sort of system to create aircraft fuel. Basically, they're going to take all the molecules cleanly from the atmosphere, from the atmosphere, and then combine them in the right chain to make fuel molecules, which they could burn in a jet engine. So this is not really any different. It's the same sort of process where you're using renewable energies to pull the carbon, the oxygen, the hydrogen, the nitrogen from the air and make these molecules, and then go use it in trucks and vehicles and everything else. So it's one of those building blocks. The question is, how efficient is that process, and is it so there's two parts to sort of reducing emissions and carbon dioxide in the air and all of that. One is, are you putting less carbon dioxide in the air? Checkpoint one. Checkpoint two is all those processes take up energy. Energy is heat. You're putting more heat into the atmosphere when you don't do it that way. So it's a balance of carbon dioxide creation versus heat, and heat's going to go somewhere, right? So it's not the simplest engineering problem in the world, to say the least.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.